Good morning. Myself, Professor Rajendra Kiwari, Department of Electrical and Electronics Engineering. Last class we have seen Module 2, which is fast Fourier transform, and we have seen what is FFT, what is decimation in time, and we have seen how does the butterfly structure has been drawn, and accordingly we have seen a signal flow graph for n is equal to 4. Today we will be looking at few more problems based on DIT-FFT. Let's start. So the contents of this chapter are, today's contents are DIT-FFT butterfly structure, numerical on DIT-FFT for n is equal to 4 length, and signal flow graph structure for radix DIT-FFT n is equal to 8. So this was the basic structure which we have gone through for the last class. So this is A, this is P. You're multiplying P with WNR. For this, here you're going to get A plus P into WNR, and here it is A minus P into WNR. So I hope you remember the structure. Next. Now today's problem. Find x of n for x of k for 2020 using DIT-FFT. Here it is inverse fast Fourier transform. X of n is your sequence. What is this DFT? It is x of k. X of k is your sequence. Its IDFT is x of n. Right. So in comparing to DIT-FFT structure, the computation procedure remains the same, except the power of Wn are made negative, and then the output is divided by 1 by n. Hence, an inverse FFT is obtained from FFT algorithm by replacing x of n from x of k. It is as similar as what you solve a problem for find an 4-point IDFT problem. Okay. So you have to draw the same structure, draw 4 lines accordingly, and looking at this butterfly, you have to go on giving the arrows and the value of W4. As I said, the computation procedure remains the same, except the power of W4 is going to be now negative. Here you are going to get capital X, which will be bit reverse order, x of 0, x of 2, x of 1, x of 3. And here the output of this would be small x1 of 0, small x1 of 1, small x1 of 2, small x1 of 3. Right? And its output, let's try to calculate x1 of 0. So x1 of 0 is what? It is capital X of 0 plus x of 2 into W4 minus 0. So the answer of x of 0 is 2, x of 1 is 2, so the answer is 4, as the value of W4 minus 1 minus 0 is 1. So it's the same kind of calculation what you have done for the previous problem. So accordingly you have to solve problem on this, right? So you can calculate capital x1 of n, small x1 of 1, small x2 of 2, small x1 of 3. So you get the answer as 4, 0, 0, 0. Now looking at this part, same structure remains for stage 2 also. You have to join first and the third one, second and the fourth one. So you can see this is my first x. Okay. So I need to calculate x2 of 0, x2 of 0. So here the inverse FFT is obtained from FFT algorithm itself. So the output is divided by 1 by n here. X2 of 0 is equal to 1 by 4. This is my output. So I need to write 1 by 4 bracket. What are the inputs which are coming to this point? x1 of 0 plus x1 of 2 into W4 minus 0. So x1 of 0 is 4, x1 of 2 is 1. 4 by 4, answer is 1. So similarly, we'll be looking at the end of this x. So this is x2 of 0, we'll be looking at this x2 of 2. Again, it is 1 by 4 into x1 of 0 minus x1 of 2 into w4 minus 0. The answer is 1. And accordingly, you can solve the problem for, you can calculate for x2 of 1 and x2 of 3. So the only consideration is that when you are solving a problem for DIT-FFT, IFFT, the input will be capital X and the output will be small x, and the value of w4 0 will be changed to negative. It will become w4 minus 0, w4 minus 0, w4 0, w4 minus 0, w4 minus 1. And at the end of the structure, you're going to divide it by 1 by 4 for all the 4 lines. I hope you have understood. So the answer of this is x of n is equal to 1 0 1 0. You can see here. So at the end you have to write x of n is equal to 1 comma 0 comma 1 comma 0. Let's take another example. Given the sequence x1 of n and x2 of n below, compute the circular convolution x1 of n star x2 of n for n is equal to 4 using DIT-FFT algorithm. Now this is your sequence. It is graphical representation. So x1 of n, at 0 you have 2, at 1 you have 1, at 2 the amplitude is 1, at 3 the amplitude is 2. So x1 of n is 2 1 1 2. Similarly, the value of x2 of n is 1 minus 1 minus 1 1. Now here we have to solve, they have given two sequences and we have to compute this by using circular convolution. At the same time we have to implement DIT-FFT method also. So this problem is similar as to Stockham's method, what we have solved. Stockham's method or DFT IDFT method. The block diagram used for finding circular convolution of x1 of n and x2 of n using FFT is as shown below. So x1 of n, x2 of n, x1 of n and x2 of n are the inputs. x1 of n, its DFT is x1 of k. x2 of n is DFT is x2 of k. Now we are going to multiply this. y1 of k is equal to x1 of k into x2 of k. We are going to get y1 of k. Now we have to take IDFT of y1 of k, which will be y of n, which is x of n convolution x2 of n. So in place of DFT, we are going to just write FFT over here, and this is IFFT. Now to find x1 of k, so the inputs are 2 1 1 2. So accordingly, this problem is been solved by the same structure what we have solved for the previous one, the DIT-FFT structure, the same. Here it will be bit reverse, it will be natural numbers and not. Okay, and you can find the answer as 6 comma 1 plus j 0 1 minus j. Similarly, you can find x2 of k referring to the above structure with the input x2 of n is equal to 1 minus 1 minus 1 1, and the answer would be 0 2 plus 2j 0 2 minus 2j. Now we have got x1 of k and x2 of k. We need to find y1 of k. So y1 of k is nothing but x1 of k into x2 of k. x1 of k into x2 of k. So you need to multiply these two. We are going to get the answer as 0 4j 0 minus 4j. Now to find IDFT of y of k using DIT-FFT structure. So you can see here we need to find the IFFT of y1 of k, and we are going to get y of n. Now this part is as similar to as this problem. So here you have to draw the same structure as DIT-FFT. Now the W4 positive will change to negative, all negative values. You can see here this should be a negative over here, sorry. So kindly change this. Please make this as W4 minus 0 and W4 minus 1. So the input is y, capital Y of 0, capital Y of 2, capital Y of 1, capital Y of 3, and the output is small y2 of 0, small y2 of 1, y2 of 2, y2 of 3, which is nothing but y of 0, 1, 2, 3. And at the end of this, we need to divide it by 1 by 4. And you will get the answer as y1 of n is equal to 0 minus 2, 0, 2. So please refer the very first problem in this video and accordingly solve the problem. Signal flow graph for 8-point TFT in decimation time. So this is a structure. We will be looking at 8 point. The standard question will be only for 8 point. In exam also they'll be asking you to solve a problem on 8 point DIT-FFT. This is A, this is P. So as you know the structure, butterfly structure, accordingly we have to draw the structure now. This is 0 stage, 0, first, second and third stage. So I hope you remember, you can understand the first stage very easily, right? So this is same as what you're trying to do. So we have to draw all 8 lines here. Okay, and between the 2 lines you have to go on drawing for X. Now, and accordingly you have to write it as W0, 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 W0. Looking at stage 2, stage 1, stage 2. So again, join the first line to third line, second line to fourth line, and join fourth line to sixth line, fifth line to seventh line, and accordingly make it as 7. So this should it is starting from 0 to 7, therefore it is 7. And accordingly we have to write W80, W82, W80, W82 here. And now coming to stage 3, join the first line to the fifth line, second line to first line to fifth line, second line to sixth line, third line to seventh line, fourth line to eighth line. And once I have drawn this, from here only I have to start the X. Now here it will be W80, W81, W82, W83, W80, W81, W82, W83 should be minus 1 as it is, and have given the relevant equations according to the stages. For this the equations are over here, for this stage the equations are here, for these equation this is the output. So it's very simple. If you find any doubt, you can contact me. Right? Thank you.